In the late 1990s and 2000, I conducted, along with my colleagues at University of Pennsylvania, Department of Radiology and Psychiatry, a study to really address the issue of lead effect on the brain itself. Because most of the studies up to the time of my study were really utilizing epidemiological studies and basically neurobehavioral studies and behavioral studies using IQ tests, using neuropsychological evaluations, which are very important and really attest to the functional organization of the brain. But the issue of confounders was debated very fiercely at that time. And it was very difficult to partial out these confounding variables when we were talking about these epidemiological studies. So we had an idea that we should actually look at the brain itself. Let's see, does lead have an effect on the actual brain, which is what we're actually talking about. So we want to see how it affects brain metabolites. And what we did is we set out to study children who had lead levels above 10, and there were moderate to high lead levels. And for the controls to see the differences between their brains and the children who were exposed to lead, we used children who were either cousins or relatives of the same children that were exposed to lead, but somehow they were not exposed to lead. So in other words, those studies were relatively free of confounding variables because the lead-exposed kids and the control came from the same socioeconomic environment, pretty typical caregiver mothers were similar, the level of home environment was similar, so we had, it wasn't as rigorously controlled, but we took naturally from that environment kids who were exposed to lead and kids who were not exposed to lead. What we used, however, is another method that is called MRS. It's magnetic resonance spectroscopy. And what it is utilizing the MRI machine, you basically are able to analyze different chemicals in the brain that have relevance to neuronal viability. So the main conclusion for our studies, I think, is that, yes, the lead affects the brain itself. It affects the metabolites of the brain. And the second conclusion is that in our study, there were not many confounders that can account for the results. So it's easier to establish the causal association with the actual lead exposure. Okay, so basically, the major conclusion from this, all these studies up to now, is that lead levels above 10, which we're talking about now, about lead levels above 10. That is, all the studies have been mostly lead levels above the level of concern of the CDC. They have been shown to have detrimental effect on the central nervous system, independent of confounders. I think we can be pretty confident with that conclusion. After all of that information that I presented to you briefly, but you'll have to trust me on that. There's a lot of information that tells us that this conclusion is pretty good, pretty savvy.